My name is Girma Bitsuamlak. I'm a professor and director of the WindEEE Research Facility in Canada. WindEEE is one-of-a-kind facilities, different from traditional wind tunnel facilities. In a way, it's a three-dimensional wind tunnel with 106 fans, and each one of them are controlled by a variable frequency drive, and it enables us to generate unique three-dimensional wind system like tornado, downburst, or sheared flow, or some of the unique wind that we see in Europe, like the Bora wind in Croatia. And because of this uniqueness, actually, it enabled European researchers to carry out research that they may not have been able to do otherwise. Yes, if I give you some of the examples, we carried out 8 different projects from 11 different universities in Europe, and with a total of 36 researchers. And the first one focuses on characterizing tornado near the ground, where it is useful to impact, the built infrastructure, and there is no other tornado simulator in Europe. So the UK team was able to come to Canada and collaboratively do tornado research, And the second one was primarily focused on characterizing wind loading on different type of form finding projects, by Technical University of Munich. They are known with the engineering of this type of forms of structure, but most of these structures, they are usually installed next to a building when there is a downwash and unique wind system. So they wanted to do the codification for that kind of structural system, and they were able to do it at WindEEE. The last project is actually very interesting. In many ports, ship containers, they are hit by thunderstorms, scattering the container, damaging the crane, and it's a unique type of system, and WindEEE is able to do that. Then Pavia team, Genoa team, in collaboration with other international universities, they spend more than 6 weeks doing different type of loading for ship container under different loading condition, for downburst loading, tornadic loading, straight wind loading, and that will enhance the safety of this type of lines, And on a fundamental level, we also did a lot of projects with Pisa University, with Naples University, on accelerated flow. These are type of flows that you cannot generate easily in a straight wind tunnels, So they were able to really do fundamental research that will be useful to enhance the resiliency of our infrastructure for future thunderstorm type of wind, and improve the Euro code, among other things, in the future. Actually, with ERIES Solar, the interesting part of the project was in places like the mountains of Croatia. You have this unique downslope wind, It looks like a sinusoidal accelerator type of flow, and the European researchers, they were doing field experiment, and they brought it to us, what it looked like, and using the capability of WindEEE, we were able to reproduce that in a controlled environment level, and do wind loading on green infrastructure like solar panel, Then compare it with straight wind, with tornado, with downburst, and then that variation will enable engineers to design very well. In Promoa, with Naples and Bari researchers, we were able to develop a database that will enable us to develop a probabilistic downburst loading for residential building. And with Naples, we worked on high-rise building and horizontal structures representing a bridge, again for this type of accelerated flow. Actually, the Norwegian team, they were doing this field experiment, and they noticed there is this unique type of accelerated flow by way of thunderstorm, and resulting in deflection of suspension bridge up to 5 meters, and they were concerned, then they came to us as part of the ERIES project, and we were doing fundamental accelerated flow on bridge for the first time. As far as I'm concerned, I have not seen anything like that studied in the literature. So basically we had a blast, honestly. Unique facilities they were made accessible to various early career senior researchers, and the fact that even from a Western University perspective we were able to work with them, we felt the research was accelerated, it became impactful, and we created a long-standing relationship. We are already writing grants together. That collaboration made us friends. When we spend in one place for a month, 2 months, doing the same thing together, there's a relationship, that contact that it produces, and we had a blast. And it helped us also to become more sustainable as a facility. You build this big infrastructure, if there are not sufficient users, it is a concern, but ERIES model is a good research model where you build unique facilities and you make it accessible to researchers, then you do impactful research in a more faster way, because all the expertise that each of the researchers bring will accelerate the outcome, the impact becomes better, there will be long-standing relationship, which is good for the future of our field.